world where space and time are intertwined, one man dared to challenge the status quo. His name? Dayton Miller. His weapon of choice? A flute. But not just any flute. This instrument held the power to unleash the ether, a pervasive medium once thought to fill the universe. Miller, a physicist by trade.
Welcome, lads and ladettes, to Aether Cosmology Reading Night, number 114.
This is going to be a review of the Michelson-Morley paper. This is a modern write-up that was done by Mikkel. I don't know how to pronounce that. But anyway, Mikkel Iakin.
Michael?
Yeah, Michael Iakin. The failed experiment that failed to fail. So we're going to get into his interpretation of what's going on here, and we're going to be giving some commentary on it as well. So the abstract: the Michelson-Morley experiment has become famous for disproving the existence of the luminiferous ether, and supposedly providing Einstein with the inspiration for special relativity. Although it has much been discussed in the literature, there has never been a comprehensive scientific and statistical analysis published of the results. The attempt to do so here uncovers a statistical, logical, and scientific problems sufficient to warrant the claim that the scientist actually did discover two effects, one which was the effect that they were seeking. This episode illustrates how a failure to apply sound philosophical principles of science can derail an otherwise excellent experiment. Indubitably. Emphasis on the philosophy of science. All right. Introduction. The conventional interpretation of the Michelson-Morley experiment of 1887 is that they saw nothing, no evidence of Earth moving through the ether, while a minority contrary interpretation of those promote the ether say that they merely saw what they intended to see, or what they had intended to see. The actual analysis of the data of the experimenters published are essentially non-existent. So in practice, both sides are reasoning on the basis of subjective impressions. The analysis presented here shows the unquestionable evidence of a period pi effect, effect that they sought, as well as a linear temporal effect of a period of 2 pi effect. The null declaration caused Lorentz to propose an explanation that strained his own electrodynamic theory. And Lorentz's electrodynamic theory, quick recap, he was using Voigt's transformations to describe the timing and spacing of the waves of which he was measuring of the electron when he was doing interferometry with that. not actual link contraction and time dilation as is modernly reinterpreted. But in the context of what he was doing, that's what he was working with, which Einstein passed along to relativists. So when Einstein came along and took the exact same framework that they were all using and just removed the ether component and said that the actual coordinates of time and space are contracting, that's the only thing that was different mathematically between the theories. Same exact framework. There is still room for debate about what exactly Michelson and Morley saw, but there is no reason to further debate about whether they saw anything. So, and that's really easy to establish by just referencing the paper here. Every now and then we'll take a quick gander at the actual paper to show some references here. So let's see here. So here's their actual measurements. There's their predicted, the dotted line. The actual solid line is their measurements. So they have non-zero values here that are outside of their window of air tolerance. And anyway, you can see here that there's a north-south, or an east-west bias to it, as it's in one direction to the east. It goes faster, and then it goes slower in the west. All right. So let's see here. One measure of importance of the event, because they always talk about it as a null, like in text and stuff, they don't actually say, like, they measured a little bit, but not enough, so we call it a null. They just always report it as if this line was just straight across and with no deviation, and it's showing any anisotropy. which it's clearly showing. So anyway, one measures the importance of the events by its degree to which it's discussed, dissected, celebrated, vandalized, elevated, and excoriated. By this criteria, the Michelson-Morley experiment is perhaps one of the most important events of all of physics. The attempt to measure Earth's speed through the luminiferous ether was reported by the experimenters as a failure in a sense that no motion was detected at all. Well, that's not, actually accurate. They never say that it was a failure or that there was no motion. They cite that they say that it was less than the values that they had expected, and that they wanted to redo the experiments at later times throughout the year to see if there were any factors that were causing it to, not be aligned. Most subsequent authors have accepted that judgment, and it has become the conventional physics interpretation. But a smaller number have claimed that the positive speed was actually seen, although it was smaller than the experimenters had hoped. That's exactly what the Michelson and Morley lads said in their paper. Given by the importance of the Michelson-Morley experiment and its effect on the subsequent directions taken in electrodynamics or electromagnetics, it is surprising how few of the judgments made about it are based on actual analysis. There does not appear to have ever been a complete and competent analysis on the Michelson and Morley data, published data. Given the importance of their experiment, especially the modern emphasis on it being determinative, this is just mildly surprising. The purpose of this present note is to do as a thorough analysis as possible based on the data from Michelson and Morley included in their article. The conclusion is that they unquestionably detected the pattern that they were looking for, and that the method of analysis that they chose was partly responsible for their incorrect conclusion. Now, I have a huge contention with this, but we'll continue on reading, and then we will touch back on my contention with this, because their equations are basically identical to the Sagnac equations, and they're basing everything off of the experimental history of Fresnel drag and their interpretation of Doppler and frequency shift and light waves and all that. So they knew exactly what they were calculating out. But anyway, we'll continue on here. So as we look closely at the data, and also raises a series of unanswered questions, however, which leaves a trail of doubt. One might argue, of course, that any such analysis is mute, and that in light of subsequent, more precise, carefully done experiments, but it is interesting that part of the legacy of the experiment was the confusion about link contraction, which went on to play a role in special relativity and continues to be a misconception in the current day. Yeah, that part's extremely true, because they conflated the timing and spacing of waves with respect to the original wavelength with the actual lab, changing dimensions and time based on time changing. So that is a huge misconception of how to interpret the results. I would also give some consideration to the attempts that have been presented in the literature to reanalyze the Michelson-Morley data. To delimit my intentions here, I do not consider arguments that question the experimental's physical assumptions, which are importune their mathematics, nearly always incorrectly, or which raise the novel physical theories outside of the bounds of conventional physics. This does not mean to disparage the novel interpretations, but it is to restrict what I have tried to accomplish. The design concept. The basic foundational and physical apparatus have been well described in many places, including by Michelson and Morley themselves. In brief, the experimenters constructed a rotatable interferometer table on which a beam of light was split in half so that the two resulting paths went at a right angle to one another. They were reflected off of mirrors and rejoined at an optical device that permitted the visualization of the interference fringes. So just a canvas, a panel for it to be projected onto. Because the two halves of the beams traveled perpendicularly for part of the path, they would have to have been speeded or slowed by the movement through the luminiferous ether to different degrees depending on the angle of their paths relative to the velocity vector of Earth heading into the ether. Since the direction was completely unknown, the table was rotated and the fringe shifts were measured at each of 16 equidistantly spaced points. If there were no ether, or improbably that the Earth was stationary in the ether, you know, that's super improbable. There would be no pattern of variation in the shifts during the rotation. Otherwise, a sinusoidal pattern would be seen, and the amplitude of which could be converted into a speed. A sinusoidal pattern showing an east-west bias throughout the day when measurements are taken at different times throughout the day. Interesting. The Michelson and Morley's concept and analysis of their experiment was entirely Galilean, and so to that viewpoint I will take here. Start by considering a single angle, one directional light represented by the vector d in bold of length d. Suppose v is the vector speed of Earth through the ether, and let theta denote the angle between the light path vector and the Earth velocity vector, noted as bold v. As usual, c is the speed of light in any direction in the stationary ether. Then we have this here. C squared times t squared is equal to the absolute value of the vector d of the length d plus the velocity of the Earth velocity through space times time squared is equal to the distance squared plus the velocity squared times time plus 2 times the distance times velocity times time times the cosine. Woo! So all that is basically, if you guys remember back to when we did the watch party of Inductica's video, when we learned about how forces line up at different angles and how it's going to impart a different amount of force based on the angle. So basically he's just lining up, he's like seeing if the plane of the interferometer is aligned with this velocity vector, how much of the velocity is going to be imparted with respect to that angle, created by that angle. So that's basically what he's going over there. And if you haven't seen that reading night, it was an awesome reading night. We learned a lot. So the left side of the square is the distance of the photon as it goes through the stationary ether in time, and the right side embodies the Galilean assumptions about the movement. So doing the velocity addition to show the timing difference with respect to the angle in the velocity vector. So then he just goes on to show that relationship there that we just talked about. This represents the outbound light upon the reflection and the return of the photon transverses d in the opposite direction. So because it's going, back and forth, he does the opposite as well, so we can get what the opposite effect would be, which have an effect of replacing theta by theta plus pi, and therefore changing the sine term, the sign of the cosine term. So instead of having it be negative, he's going to add these up to be like a singular positive value instead of it being instead of it being one way for the speed of light matching the two-way speed. This is going to show that they're basically it's going to make it so that the one-way speed is different for the whole path length by flipping the sign by flipping the sign there.
Like,
right?
Do you think it's possible that mathematically speaking, he could have jammed any more relationships between c squared and v squared? Or rather, v squared and c squared? Do you think that could he have stuffed any more of them in there? Like the other little teeny places he could hide them in other hidden exponents where there would be another to the exponent of v squared over c squared. He could get that hard, I guess. But that would be a challenge, wouldn't it?
Yeah, I mean, all this to just justify doubling the amount that was measured, essentially. Because this is the same kind of thing, like, as we go on to read the interpretation here, we've seen this a couple of times from Marinov, Manera, and a couple other people who change the interpretation of how the fringes should be interpreted so that they could get a more favorable velocity. And what I was talking about earlier with this, what Michelson, Morley, how they were interpreting it was through, basically what is now the Sagnac effect, which is the correct way to interpret the velocity to fringe reading relationship. And this is all like, extracurricular activity, like Stone was saying, to packed in a bunch of variables here to describe like, hey, if the actual velocity vector is this direction and we're moving in this direction and therefore the interferometer is aligned in this direction, we're only going to measure this much. And if I do this function here to change the sign of the relationship for plus and minus to just make it positive, then I can turn the comparison of the there and back trip to make it like, essentially doubling the fringe pattern, which if you double it, it's going to go from what was it, like 6 to 14 or 6 to 7, so it's going to go to like 14 kilometers a second. But anyway, that's what he's doing there. So based on the Maclaurin approximation, we have the square root of 1 minus u squared is, I forget what this means, but it's not equal. It's
essentially
like
equal to.
Yeah, it'll like trend to it or whatever. Essentially equal to 1 minus the u squared over 2. And I think u in this relationship is velocity. It should be. But anyway. Was used by Michelson and Morley, which is quite accurate for the small speed that they had anticipated. So like, compared to the speed of light, Earth's velocity of 30 kilometers a second is like 0.001% of it or something. So if you round it to 300,000. Let us now replace D with D sub D for the first arm. So now he's going to break it into the left and right arm components, and we're just looking at more of the same thing, where he's going to turn that into a different, mathematically turn it into a different interpretation.
Through the use of average D, exactly.
Yep. Presumably, it would have been impossible for Michelson and Morley to have made the two arms of equal length at the level of precision that would make it ignorable. For convenience, let us use D bar for the average length and delta D for the half of their difference, so that D sub 1 and D bar is equal to D bar plus D delta D, and D sub 2 is equal to D bar minus D delta D. For the second round trip time, the sine and the cosine are interchangeable, and the sine of one of them is changed. So again, making it the full value instead of half of what it should be. Thus, the difference between the round trip is given by this equation here. Therefore, the pattern of the time difference of the time differences and anything that depends on it would have been a period of pi, which would vanish, and only if the Earth was at a velocity or 0. So now by reinterpreting and combining this, the Earth can only, like, that's another false thing too here real quick. Like this measurement alone is kinematics, right? So the Earth could be moving really slow, or it could be moving, or it could be stationary, and there could be a medium that's moving in between the Earth and the light source. So it could go either way. Like this doesn't definitively mean anything about the velocity of Earth's role in this. It could go either way just off of the measurement alone. You would have to introduce additional factors to make the determination of that. So there could be a velocity measurement and the Earth could still be stationary, and that it wouldn't have to be 0 across the board for the Earth to be stationary. Only in this recombined average vector situation is his interpretation of it. Note that the difference between the arm lengths would at most contribute a nearly constant term, which would not interfere with the periodicity. And if the second arm were not exactly perpendicular to the first, then the form given by this equation, the period would stay the same. Consequently, so long as one focuses on the period pi pattern, the small differences in the length arms or their departure from the angle would be pi over 2, would have no effect. It is worthwhile noting that the returning light beam were it is worthwhile noting that if the returning light beam were affected by either the reflection or due to the one-way speed not being equal, then the period 2 pi effect proportional to V over C might be detected. Now, this is exactly Well, it was detected. The proportional ratio to V over C. They used the Sagnac equation. That's all the interferometer interpretations are based on, that exact V over C relationship. And that's exactly what this measurement was. This is exactly what they... So if we scroll up to the equation that they used, all of this right here, velocity of light, velocity of Earth, distance of the apparatus for the light to travel, basically the path length light has to travel over the plane of the interferometer, the time it takes for said light to go across those arms, parallel and perpendicular. And this is what this all reduces to 2 times the distance. Oops, it's down here actually. Sorry about that. It reduces to this down here, 2 times the distance times V squared over C squared. So that's all it's saying. This is the Sagnac equation. This is the linear version of the Sagnac equation. You would just replace velocity with angular velocity, and you would replace d with area, and you would, and this is the exact this would make the exact same prediction. Okay. So that's actually what they measured. So since the theoretical isotropy of light would pertain to a vacuum, but the experiment took place in air, one cannot automatically discount for the longer period effect. To be clear, I have presented these computations to clarify the analysis below, but I do not claim any originality. For example, they have essentially been published by Articicolo in 1969. And real quick on the note about the air and the vacuum situation. So the modern reproductions of these experiments take place in a vacuum, where they take out all of the, essentially all of the ether in the vacuum, and it reduces the amplitude of the phase difference. So they get a lower velocity difference reading. So they interpret that as the speed of light being isotropic. Whereas when you have a medium like gas or air or whatever, right? Whenever you do that, they measure they measure a what is it called? A sidereal fluctuation and an annual solar fluctuation that corresponds to the equinoxes, where the speed of light reaches its fastest speeds on the equinoxes and its slowest speeds. So they do measure these things, but they're not at the velocities that they need to. So they ignore them and say that they're zero. The data analysis. The only data we have from the experiment was what was reported in the 1887 article. 6 runs were given, each consisting of 17 fringe shift measurements, and the initial measurements were being repeated at the end of one rotation. Each run was in fact an average of 6 identical runs made consecutively. 3 of the summary runs were started at noon and at 3 at 6 p.m. in the evening, over 4 days in July of 1887. A rotation took about 6 minutes, so each of the reported summaries was based on 36 minutes of observation. The interferometer table floated on a pool of mercury, so it could be rotated at a constant rate with a negligible vibration. One experimenter, Michelson, had to follow the optical eyepiece around the table, followed the table around with an eyepiece as it rotated to look at the fringes as they were projected on that canvas panel. With the measurements being taken rather quickly, the effort that was required evidently caused some physical strain.
I wonder how many times anybody uttered the word ergonomic during its construction.
Dude, and then can you imagine Miller's doing it for like 25 years?
Like a million times. Yes.
Dude, I don't blame Shanklin now. Like, looking back on what it would take to make the measurements, he was probably really upset and bitter. All right. So let's see here. Since this effect dominated the, let's see, I might have skipped a section here. Physical strain. Yeah, the fringe shift runs are shown in figure 1. They all exhibit an obvious near linear trend upon which the experimenters made no comment. Since this effect dominated the data pattern, it is unclear why Michelson and Morley did not track down the cause. because the cause was that the Earth wasn't moving fast enough to how established science knew how to interpret the fringes. Although their instrument was one of exceptional quality, it was assembled and tested only over the course of about 2 months, and we have no evidence on what quality testing they did. Now, Miller went into more extensive testing for these and their calibrations and whatnot, and to measure down to 1/100th of a wavelength, it certainly had the capability to do that with an accuracy of about like plus or minus 0.02 of a fringe, which is I forget the wavelength conversion, but it's definitely super able to do that. And then under certain conditions, Miller was able to get his to go to 1,000th of a wavelength. But he didn't even like use those for his actual interpretations and stuff, but he was making just as accurate readings when he fully calibrated it and got it going and all that. So definitely accurate enough to make the measurements that they were trying to get here. Let's see. The most frequently published surmise that there was a temperature effect, but has shown in the analysis above any uniform change in the length of the arms would have a multiplied effect, not added to it. And although the differential change might have appeared as an additive effect, it would have been very consistently different between the two arms as they were rotated, and it is not clear how that could have occurred where it would be symmetrical. Measuring the temperature might have clarified its potential effect or lack of effect, but this was not done. But again, Miller did extensive testing on this to figure out how ambient temperature affects the measurements. More surprisingly, evidently no control runs were done without table rotations to assess the presence of the magnitude or potential disturbances like temperature changes. Michelson and Morley removed the temporal trend as the first step of the data manipulation, but they failed to report how. The suspicion has been that they took out the linear term in order to make the last observations equal. For the analysis, I removed the linear trends as part of model fitting. So Stone, you had some commentary on this. Did you want to go into that now, or do you want to go after we finish?
Oh, I think right now is probably good timing. We're just showing them the raw data here for all 6 runs. But like I was saying,
that you wanted to show.
Can you hear me?
Yes.
Okay,
sorry,
good. Yes. I'll be sharing my screen right about now, so that we can convert what this looks like. If you want to just show figure 1 right out of the paper to these people first.
Absolutely. Here we go. Here's
exactly. So you have N1, N2, N3 on the left side. That's noon, day 1, day 2, day 3. And then E1 and E2 are 6 p.m., 6 hours later, day 1, day 2. And E3 is actually day 4 at 6 p.m. So that's how they go together. But for me, it's all about the y-axis. And you can see that out of all 6 of these, none of them are the same. And I don't just mean where they are in terms of magnitude. I mean their spacing as well. Like even between N1 and N3, where you can see 10, 15, 20 on N3 and 15 to 45 on N1 kind of thing, that it's, it's twice the stretch, if you know what I mean. Yeah. That one is zoomed in and the y-axis 100% beyond the other. Like there's just no way that N1 and N3 are anywhere similar to each other. N3 occurs way closer to 0 and dips half the slope, yet they're drawn identically here. Is that crazy? That's absolutely crazy. I find that astonishing in terms of how misleading it is. Okay, so of course what I did was I regraphed it in composite. And there, if you guys want to take a peek. Let me know when you can see that.
Yep, we got it.
Okay, well, here it is all nice and zoomed in. So N1 over here on the left, this is all 16 or 15 points that you want to take a look at. That would be counterclockwise, of course. So these would be north and then west and then south, and then east. Same thing for the 6 p.m. samples here, where E3 was taken on day 4 at 6 p.m. But we're going to find out, and he's going to mention it right away, that for these, he was turning counterclockwise, and for these, he was turning clockwise. So again, another degree of counterintuitive interpretation in the presentation. Of course, so what you need to do is flip those. So that's what I did. I flipped them. So you can see across the bottom here that we're counting up to 15 and then down from 15 to 0. That's a total of 16 points, 0 through 15 inclusively. So here, again, we're going counterclockwise now, that this would be north and then west and then south and then east and back to north by the end of it. So this is how they actually interrelate. And here we are on day 4 climbing instead of dropping like day 1 and 2. I find that interesting. And again, here, this is interesting that we're dropping on 1, rising on 2, and dropping on 3. I find that really weird.
Dude, that is so
really weird.
That is so awesome. See, like, man, when you look at the graph that he presented in figure 1, right?
It's nothing like this.
It looks, yeah, it makes it look, he like artificially did it so that it looks like it supports his argument, but the actual data doesn't show the trends that he's trying to.
Yeah, I don't know what the hell he's doing, frankly. I really have no idea.
He's trying to find Earth's velocity. And that's like, dude, this is what happens when you try to find Earth's velocity.
Okay, I killed my screen share because you're looking at yours now too. Okay, good. Yeah, that was most heinous, I must say. I mean, you can see them here that in N1, in these 6 blocks, that there's a down and an up and a down between N1, N2, N3. So I guess it does show that much. And the same thing with E1, 2, and 3, that there's 2 sloping up and 1 sloping down, which is really kind of weird. But it's all about the y-axis and where these actually sit. You know, for me, the composite tells you so much more about this data than what he presents here. I'll leave it at that. As we were.
Sir. All right, so that was figure 1. A plausible alternative explanation for the linear trends was indirectly provided in the article where Mickelson and Morley remarked that the interferometer was rotated counterclockwise for noon runs and counterclockwise for noon runs and clockwise for evening runs. This is suggestive because the 3 runs show a decrease and 3 show an increase. Of one of the images that the sense of the rotation produced a consistent trends, then the pattern shown in figure 1 would be inconsistent with their description. Further, if instead it were the case that the runs were done at the same time of day, would show that the same temperature effect, and then again their data would be inconsistent. This does raise the possibility, however, that the data was not entered into the published data table correctly as to the time of day. If that were true, in fact, it would invalidate the approach that they took for the analysis. Figure 2 shows the raw data with the time trends removed, along with the values fitted according to a model with 2 sinusoids. Sinusoids, thank you. Sinusoids.
Yeah.
One of the period pi and the second of a period 2 pi. Yeah, I knew I wasn't hitting it right. I was like, there's something I'm missing here. Thank you. The correlation between the observation and the fitted values were displayed as a rough indicator of the quality of the fit. As indicated in the analysis above, the period pi pattern was primarily of interest, but it is the convention of the analysis of the periodic data to include all harmonics below of the one of interest, which is the case would just be in the period of 2 pi sinusoid. This decision was justified in light of subsequent analysis. It is to be noted that N1 and E2 fits of the lower quality than of the others, which would be caused by either excess of experimental air or a temporal pattern different from the other runs. Ooh, there's a temporal interjection here to explain that. So here we're looking at the sinusoids. going through the data set there. So the figure 2 is the data time trends removed with circles, the values fitted by least squares to model the sinusoids of a periods pi and 2 pi, where r is the correlation between the observed fitted values.
Yeah, N1 and E2 have lower R values.
Yeah. So the closer you get to 1 on this is like good, right? And then
Yeah, it's just this. Is it a smooth line of data, or is it all over the place like the top left one is? Nowhere near the
right,
line. You know what I mean?
right,
How far do they have to go to produce the fit? That's
right.
what drops the number.
Gotcha. Cool. All right, the two sinusoidal components are fit and shown in figure 3. Unexpectedly, the longer period effects were, if anything, greater than the shorter period effects, indicating that there was some kind of influence related to the full rotation. Going back to the underlying mathematics, a difference between the outbound and return light velocities would contribute to a period of 2 pi effect proportional to V over C. If this were the source, the longer the period of the component, then the experiment might have solved for the long-standing problem of the one-way speed as opposed to the two-way speeds, while at the same time demonstrating that the potential ether effect on the one-way speeds. You don't say. So we got figure 3 here, comparing the curve fit to the, what was it, the period of fluctuation or whatever in here. So let's see here. What was I just at? Demonstrating their potential speeds. Okay, the fitted values of the periods pi sinusoids and the period 2 pi sinusoids are dashed. The positions in terms of 1/16 of the rotation effect is in the fringes here. So comparing the rotational effect on the fringe proportionality. It is noteworthy that the phase offset of the period pi components appear relatively uniform across 5 of the 6 plots, whereas the phase offsets of the period's 2 pi components vary considerably. In theory, the offsets would be influenced by the direction of the interferometer's arm at the start of the run and possibly on the adjustments of the mirrors. Michelson and Morley did not make any mention of any standardization of the initial conditions, but they did label their graph with north and south and east and west, suggesting that they might have started each run with the arms pointing to the north. That would make sense. That would be my assumption as well. That's how I would do it if I was going to interferometer velocity test Earth through space. Then they may have altered their data in the graph, however, because it does not correspond to their data table, in this case, figure 4 would show the potential direction of a period of pi effect, which the plots align so that the north is upward, but the east versus west depends on the sense of rotation. 4 directions are necessary since we can only say that the actual directions that would correspond to the 4 extrema of the periods of pi effects. The plots in the figure 4 do not make any adjustments for the sense of rotation, so that the case where the sense was reversed would need to be flipped horizontally. If the experimenter's word were taken at face value, the counterclockwise rotations at noon would need to be flipped to make the directions of the plot line up with the evenings in the east-west directions. So here we're looking at what that looks like. The potential projections of the velocity vector onto the interferometer table surface for a period of the period pi component. Scales are in the fringe shifts. No adjustments are made for the sense of the table rotation. The bold arrow represents the arm initially pointing to the north, and the plot to the north would be in the upward direction. Okay. The phase offsets issue a relevant question to whether the results indicate a terrestrial effect, something carried out by rotation of the planet, or extraterrestrial, caused by the direction of motion through the ether. From the three-dimensional geometry, the extraterrestrial effect would appear as a 1/4 rotation, which in figure 4 would pertain to the bold arrow, but this is unfortunately confounded with the sense of rotation. Accepting Michelson and Morley's claim about this would amount to saying that a horizontal flip of the noon plots in figure 4 should give the same configuration as the evening plots, but with the bold arrow rotated 1/4 turn. Clearly, this does not happen. Given the doubts of the data, it is probably the case that no speculation about the terrestrial/extraterrestrial cause is warranted. The experiment would have been better designed if the times at which the runs were carried out were not confounded with the issue of geometric rotation. Altogether, one might roughly group the 6 runs into 3 where the interesting period pi pattern was more pronounced, and there were 3 less. It was and 3 where it was less so. There we go. They're, in a sense, looking at the period pi patterns, that their quality might have improved over subsequent runs. So here we're looking at the period pi runs. So the interference, table 1, interference from the fitted models, amplitudes, and the square roots of the sums of the squares of the sines and the cosines components of the fringe shift data. The p-values are for the hypothesis of a 0 amplitude. The speed is corresponding to Earth through the ether. Offsets or sinusoidal phase offsets in units of 1 rotation, so 1 corresponds to 2 pi radians. So let's see here. If you do his assumed velocity vector correction differences, with the corresponding angles, you'll get a larger fringe, and then the p-values are given for that fringe reading with respect to a 0 amplitude in the fringes. So his null hypothesis would be that there's for the hypothesis of a 0 amplitude. So his null is that there is an amplitude. All right. So the statistical analysis from the model fits the table 1. With regard to the pattern of interest, the first day's amplitudes would not be counted as being detected, and when we recall the noon runs was potentially less reliable. Similarly, the evening 2 amplitudes is not technically significant by prevailing standards, although the low p-value does indicate a lack of support for a 0 value. The other 3 runs would be statistically significant by any standard. The period 2 pi amplitudes in each case are larger than the period pi amplitudes, and in some cases considerably so. And 5 and 6 would be considered to have been detected by conventional standards. There is, therefore, virtually no question about the fact that the experiment detected the effect of what was sought. So by reinterpreting how the fringes should be read, he's saying that there was a non-zero amplitude of fringes that corresponds to a specific velocity component. And now he's going to get into what that velocity component would be derived if you were to square the difference between the newly established fringe pattern. Using the computations of Michelson and Morley that they gave in their article, the speed of the Earth through the ether would be 30 kilometers a second, where A is the amplitude. So basically what we went over here, how the phase difference is going to change based on the velocity. He's just giving a rendition of that would be 3 times the square root of 10a kilometers a second, where a is the amplitude given in table 1. The resulting values in the speed row of table 1, so that it is reasonable to summarize the results as an estimate between 6 and 11 kilometers a second. By their reckoning, the experimenters concluded that with respect to the expectation of 30 kilometers a second, that there was probably less than 1/6 and certainly less than 1/4 of the value, and it is probably below 5 and certainly below 7.5 kilometers a second, which they did say in their paper. In the light, the graphical and statistical results account must be given for why Michelson and Morley declared their experiment a null. There were three mutually reinforcing errors. The first was that the experimenters based all their calculations on the assumption that Earth's velocity vector lay in a plane determined by the surface of the interferometer table. Therefore, there is of course no evidence for this, and consequently, the only speed that they could have measured would have been the component of Earth's velocity in the interferometer's plane. So, like, again, if they're not directly lined up, there's going to be an offset on how much velocity is going to be imparted on that speed of light to be changed. So he's making the argument there that they were off on how they were trying to associate the alignment of the interferometer to the velocity vector and the velocity measured relationship. So let's see here. In other words, the value of v was the magnitude of the orthogonal projection of the velocity vector onto the plane. If the velocity vector had happened to be perpendicular to the interferometer's surface, they would have seen no effect no matter how high v was. So they predict, because that would be the point where there's least amount of change between them angle-wise. So they would predict.
Okay, so he's still saying if, though. Why is he still saying if? Why didn't he just go compute it himself? Like, why didn't he just bust out the astronomy program and say, okay, here's Earth in its orbit. Here's where it is that day, that night, that noon, that afternoon. You know what I mean? Those days. Here was the orientation relative to the sun when they were taking their measurements. Why didn't he do that? Why is he still saying if?
Because it would poke a hole in his entire reinterpretation of trying to make it doubling the measurement viable. It would interfere with his conclusion stone. But yeah, he could have verified how this magnitude of angle offset would affect everything.
Is that just too much geometry for this guy or something? I don't know, man.
Dude, you would think he'd be super into it. If the velocity vector had happened to be perpendicular, they wouldn't have predicted anything. To the extent that it was close to perpendicular, they would have seen a reduced effect, as indeed they have claimed to have done. This problem is mentioned sporadically through Cartmill in 1937, Miller in 33, Consoli in 1928. Now, Consoli actually did a harmonic analysis and statistical analysis of all that, so it's kind of interesting that his premise is that there hasn't been one done, and he's specifically citing someone who also did one. And then they were especially re-emphasized by Manera in 1998. And Manera we talked about earlier because he actually reproduced Miller's work, and over a period of 3 years, he took interferometer measurements and showed the same sidereal and annual solar relationship that Miller showed. But again, he was reinterpreting how to read the velocity out of the fringes so that he could get a higher amount. And he went for the extra galactic velocities. So he came out with a number that was like 700 something kilometers a second or whatever, because he was trying to go for the CMB velocity. He was going for the gusto. So anyway, all these people produce different velocity amounts with respect to the fringes. But again, like I talked about earlier, there's only one correct way to interpret the ratio that makes any sense with respect to interpreting actual velocity and measurements. So if you use that, then Michelson Morley hit it spot on, and all of this is just extracurricular activity as we continue on. Yeah. So the second error was compared to the results with what they had expected as opposed to the speed being 0. They took the Earth speed around the sun as approximately 30 kilometers a second as their expectation, despite the fact that any non-zero speed would have supported the existence of an ether. Yeah, but because they knew how to correctly interpret the interferometer readings, they knew that any value sub 30 kilometers a second or thereabouts would be a no-fly zone. Even if one granted their expectation to interdeterminacy of the first error would have been nullified their null assertion. So let's see. The third error was data manipulation. In many ways, this is the most surprising mistake. The whole basis of interferometry is the interference effect superimposed waves, which have been demonstrated for light by Thomas Young around the 1800s. Well, not only that, but there's Fresnel who showed the velocity ratio of a moving medium and how that affects the light, and Doppler frequency shift when they would split the light spectrum and measure the frequency and all that. They were measuring, like a beat frequency is literally the proportional change with respect to the original frequency based on X amount of velocity. So they had well established how to interpret a fringe pattern. The effect is computed in figure 5, showing the amplitude on the averages of the sine of 2 pi omega t and the sine of 2 pi omega t plus delta, which it depends on delta. Exactly the same effect occurs for the type of sinusoids that Michelson and Morley recorded. By averaging the 6 runs in order to produce a single noon and evening runs each day, they risked reducing the magnitude of any effect of the potential phase offsets, which one would have expected due to random variations. Moreover, because they regarded the second half of each run as a replication of the first half, they averaged the two halves together to create the result for each noon and evening run, going now from 0 to pi. And is that 0 or is that what is that supposed to mean?
Yeah, that's from essentially 0 to 180 degrees in the circle.
Gotcha. Going from 0 to 180 degrees. Finally, they averaged over the 3 months. And finally, they averaged over 3 noon runs to produce the overall noon signal, and similarly for the evening runs. Consequently, the very likely reduced effect they wanted to see by 3 successive averagings, they just canceled it out essentially. The oopsies, they canceled it out. The result of the second 2 averagings is shown in figure 7. This does not correspond to the graph given by Michelson and Morley's article in 1887, which does not appear to be consistent with their own data. It shows that the amplitudes, rather smaller, would have been indicated by the correct analysis. The graph given in the article, which constitutes only an approximation of the analysis, is on the squared velocity scale. That is the units of v squared over c squared. So the tiny differences are rendered infinitesimally. This was partially hidden by not providing a notated labeling of the graph. Here we go. So we got the extrema, phase offsets, sine interference. The positive and negative amplitudes of the sinusoid compose of two sines, the same frequency but different phase offsets. The effect is independent of the frequency. Yeah,
it's just offset by pi, half a rotation. This is what you're expecting to see.
Gotcha. So there is an additional issue with the phase shifts. As stated, Michelson and Morley wrote that the noon runs were counterclockwise and the evening runs were clockwise. This implies that to make the noon and evening runs homogeneous, the time order for them would have to be reversed. Moreover, the 1/4 Earth rotation between the daily runs implies the 1/4 rotation of the period pi signal. Thus, consistency of the pattern of the results would imply that when these adjustments were made for the 2 signals on each day should be in phase. The results in figure 6 suggest that the third day gave highly consistent results, but the 2 previous days did not. We can make several remarks about the experiment, some that we can justify with the data and some that remain speculative. There is essentially no doubt that Michelson and Morley succeeded in detecting the effect suggested by a Galilean analysis of their design. What they saw was an unknown fraction of an actual speed due to an unknown inclination of Earth's velocity vector in the surface of the interferometer table. There are 2 anomalous effects in the data, a linear time trend and a full period pattern. Both, at least, are as strong and convincing as the signal of interest. The method of data manipulation and presentation almost certainly reduced the effect that they were seeking, although we will never know the magnitude of this reduction from the data of the underlying 36 runs was not preserved. So yeah, I remember Bennett talked about that the that the actual full data set was destroyed, and we only get this truncated version,
Averaged and smoothed.
averaged and smooth, so that we could yeah, it's been pre-smooth, so we could never tell anything for certain about it ourselves. So shout out to the homie for trying to like deconstruct it and all that. But yeah, trying to make it then fit back into the heliocentric paradigm is where I would argue he went wrong. Figure 7, the averaged data over the noon runs and the evening runs folded so that the second half of the rotation is averaged with the first half. These were the basis of Michelson and Morley's conclusions, in which they used the amplitude of 10 as their expectation.
So they're folding west over top of east. Instead of 15 points, we're looking at 7.5 or 8. 16 points rather. We're looking at 8 now, because it's the second half of the rotation superimposed over the first half.
Nice. So is that similar to how Shankland was folding up the data to analyze?
Yes, very, very much exactly the same.
Gotcha. So again, this is like a really weird third order interpretation. Whereas like just the reason Michelson and Morley didn't do this is because the geometry of their apparatus is second order. So as far as we're willing to take it was that. And so like doing this where we're like, okay, maybe the velocity vector, is different. Maybe we could adjust all these factors and reach our conclusion by reverse engineering what it should have been, That's probably why they didn't do it. I would suspect, because it would be super obvious. So anyway, having made the positive assertion about the data, there remained difficult problems. One would want a physical explanation for the anomalous effects, specifically the linear trends that were related to the sense of the interferometer's rotation, and then the data do not correspond to Michelson and Morley's description. This in turn clouds the extent to which one might cite the terrestrial rather than the ethereal cause for what they clearly did detect. We do not have the original 36 runs, so we cannot subject them to the contentment of modern analysis. No control runs were reported, nor were there any daily or yearly repetitions, except for Miller's data, which was also destroyed and showed to us in a similar fashion, where we have like segmented raw readings, but no ability to deconstruct long-term analysis or whatever, or anything like that, like these people supposedly were able to do. There is no evidence that Michelson and Morley did not carry out the full testing program before doing the experiment, due to the short time from decision to go ahead to the actual experiment itself. This is further supported by the anomalies, and that the fact that there seemed to be an improvement of the results with time, indicative of perhaps learning the process over the 4 days. Taken in total, the data on the last 2 runs are higher quality, suggesting that one might regard the first 2 days as preliminary runs. Existing reevaluations. There are no satisfying analysis of the data from Michelson and Morley that they published. Nearly all mentions of the experiment restrict themselves to either the verbal conclusion or the rehearsal of Michelson and Morley's approach to their data. The misstatements are common, including assertions about the experiment being repeated many times throughout the year and at different latitudes. A number of authors appear to go into more detail, but they simply give elaborated accounts of Galilean transformations. There are various attempts to argue that the conventional Galilean analysis is mistaken, but I have made no attempt to collect these. Here, I cite a small collection of articles that I have found that are relevant in the way of analysis that I have presented. I have not included claimed analysis where there is a credible evidence of misinterpretations or fraud. Ooh, dang.
No, that's misrepresentation.
Oh, is that what it's? Oh, sorry about that. Misrepresentations or fraud. So Hicks, 1902, carried out a foreboding complex analysis of the equations underlining the experiment. Oh, we'll definitely have to read that. Focusing on the punitive shift of the wavelength caused by the reflection of the mirrors, he claimed that the effect of the desired sort had been detected, but proved no estimates of the actual effects, relying on the data tables and an unlabeled graph to make his points. A classic unlabeled graph, Stone.
Let me at him.
There's the culprit. We found him again. Guys, we found the velocity. And we also found the distance. We found whatever we need. It's in the unlabeled graph.
We just don't know what it means.
The linear effects were attributed to temperature change with no evidence presented. He criticized averaging over the runs that were performed by Michelson and Morley. The Hicks article was later retracted due to serious error, but nevertheless stimulated Morley and Dayton Miller to try further experiments with the Michelson interferometer. Shout out to Morley and Miller. Peace be upon them. The most readable and accurate account of the ether drift experiments was by Miller in 1933. Typical data from the Michelson and Morley were plotted using 2 and 3 times the averaged figures. Miller noted that the effects were small but non-zero, without any formal analysis. We'll have to reread that one.
It's just like his quote. He said, I keep tried it this way and that way, and I tried it every possible way, but I just can't get zero.
Yeah, I vaguely remember that. Because, yeah, Miller was so, like, humble and honest about it. He was, like, trying to be like, I don't know. Like, he came to the conclusion, like, I don't know what this is, but this is the velocity. This is...
I want to help the mainstream, but they're not helping themselves. What do I do?
Crazy, dude. He was like, this is just what it is, as is. I don't know why, but this is what it be. All right. He included an exhaustive 3-dimensional geometric analysis on the consequences of Earth's velocity vector changing its orientation to the surface of the interferometer, primarily a diurnal effect, but also having a yearly effect. This performed on the basis of his estimates that the velocity of the direction of Earth through the ether from his own data. He noted that the strong diurnal effect would cause results to vary over time of day, as well as terrestrial latitude, perhaps making it rather difficult to draw any conclusion from the Michelson-Morley experiment in this regard. The final conclusion from his data was that the direction of Earth's motion or movement placed it about 20 degrees minus 30 degrees from being perpendicular to the interferometer table of the experiment. So yeah, I think he had it going towards some direction in Leo, and then what's his name? The gentleman from Oregon who did his own analysis and determined that Miller made some sort of error and actually reversed it and had the direction going in Virgo. So like, I don't think any of these guys know what direction based off of the magnitude that they're getting at the time of day.
It is kind of a circus, isn't it?
It can literally be like whatever you want, apparently. But yeah, so this is how they're trying to relate it. From being perpendicular to the interferometer's table would have detect. Okay, yeah. Okay, we'll back it up a second. So the final conclusion from his data about the direction of Earth's motion placed it about 20 to 30 degrees from being perpendicular to the interferometer of the tables of the experiment, which would imply that the detected fringe shift would be 1/3 to 1/2 the actual shift. Miller made many thousands of careful observations in varying locations and latitudes over a period of more than 2 decades.
Altitudes.
Thank you. Altitudes. What did I say?
That's the second time you said latitudes.
Oh, did I just... Yeah, I read locations as latitudes. Anyway, varying locations
No, previous paragraph.
Yeah, and altitudes over a period of time in 2 decades. Interestingly, Miller noted that there was an observable linear and period 2π components in all of his experiments, as well as in the Michelson and Morley data. He accounted for this as a result of a tiny rotation necessary for one of the mirrors in order to bring the fringe shifts into view. An argument he copied from Hicks in 1902, elaborated in 1928, which has been disputed by Vail in 1934, who claims that the mirror adjustments could only affect a period or could only affect period pi effects. Notably, and period pi effects are the rotation effects, right?
Yeah, for the first half turn.
Gotcha. Okay, so notably, with regard to the speeds estimated in Table 1, if Miller's directionality results were accurate, then Michelson and Morley had actually detected the total speed somewhere between 12 to 22 kilometers a second or 18 to 33 kilometers a second. It is, of course, remarkable that Michelson and Morley would have missed this implication of a three-dimensional geometry for their design, but there is independent evidence that they had also missed other things. Okay. In 1886, they had repeated Fizeau's experiment and confirmed his results, which was that the ether was partially dragged along by the matter that it had penetrated. Yup. They had interpreted that to mean that the ether was unaffected by matter moving through it, contradicting their own result while solidifying the argument to justifying their eventual interferometer experiment. They interpreted this to mean that the ether was unaffected by matter moving through it, contradicting their own result. Yeah, so when they I think that goes back to Arago and Airy and Hoke, where they had kind of reversed the claim to say that like the ether is bouncing around in the medium to cancel out velocity components. So they had this like weird backwards interpretation. When it came to measuring Earth's velocity, somehow the ether was bouncing around, canceling out the effect in the apparatus. And then when they were measuring, the velocity of water through the apparatus, they had no problem with that. Like, it gets weird. So let's see here. Even more curiously, Michelson evidently believed that the ether entrainment hypothesis for the rest of his life, without noting that this effect might have been diminished due to the apparent interferometry results below his expectation. So I think this is just like the diehard adherence to the, to the Copernican principle and Kepler's laws and all that, like really, truly trying to make it real. Because the measurements that Michelson took, directly contradict their cosmological velocities, even at somewhat vague. Go ahead, Stone.
No, go right. I was just about to say and agree with you. It is a puzzlement. Quote.
And he just chose to hold on to it his whole life and was like, no, but it's real. We're still moving. It just doesn't work or whatever. Perhaps the earliest actual analysis done by Hansky. Thank you. Although he used the statistics that were said to be appropriate for detecting the periodic pattern, he applied it to the multiplying average data published by Michelson and Morley in the effect had been artificially suppressed. He mentioned that the problem would be resulted from Earth's velocity vector not lying in the plane of the interferometer, but he drew no conclusion from that and gave it no particular attention. His conclusion that the Michelson and Morley were right and that their trends to ring rather hollowly. Statistical methodologists occasionally methodologists, thank you, occasionally use data to make the help me out on that
pedagogical as in the study of teaching.
Pedagogical. Yeah, pedagogical. Yeah, there's a gog in there. Yep.
Isn't this fun?
I see it, dude. Learning words is dope. To make the pedagogical points, for instance, Carver in 1993 used them to make points about the hypothesis testing. From an ANOVA analysis, otherwise specified or unspecified, he reported that the p-values are greater than 0.001. He found he was of the opinion that he would have had to have made a mistake in the report because, quote, the eta squared value associated with the significant effect that the direction of the speed of light was 0.005. This means that the Michelson and Morley have been forced by the journal editors and referees to do a test of statistical significance. They could have minimized its influence by reporting this effect size measure, indicating that it is less than 1% of the variance of the speed of light was associated with the direction. There seems to be no good excuse for ignoring the effect size when a p-value is reported. He goes on, fortunately, Michelson and Morley do not corrupt the scientific method by testing the null hypothesis before they interpreted their data with respect to their research hypothesis. While it is true that Carver's purpose was didactic rather than an attempt at a real analysis, and while it is also true that his point about the hypothesis test without the effect estimates is right, his reports are wrong. He reports the wrong effect estimate. The eta squared statistic compares the squared portion of the variation of the signal Michelson and Morley were seeking to the total variation in the data, including the anomalous linear trend in the period 2 pi effects. He mistakenly cited his estimate in the term of the speed of light, when in fact when it is in fact with respect to the fringe shifts. He further missed the point that the purpose of the experiment was actually to detect any fringe effect, regardless of its magnitude, which is almost the definition of a situation in which a hypothesis test should lead to an analysis. In this case, a profoundly misguided opinion in the statistics-oriented journal was injected into the literature to be quoted by the unwary. The separation of statistical methodology from science in the last half of the previous century, has done neither activity good. Cahill's program of research in 2005 questioned the null effect in the interpretation of the experiment. He showed that the patterns of the individual runs but carried out no statistical analysis. Cahill's interpretational argument accepted the Lorentz-Fitzgerald contraction but argued that the index of refraction of the gas in which the experiment was done is a critical component of the design, and he showed the consequences of taking that into consideration. A nearer approximation to a complete analysis was reported by Consoli and others. Shout out to Consoli and Placino in 2019. Although they actually fitted the data with the appropriate sinusoids, instead of using the implied standard deviations of the estimates from the analysis, they computed the six amplitudes and apparently reasoned on the basis of their averages. In other words, the variations of the data that they used for precision was the between run components rather than the appropriate within run component. Although their method was erroneous, they reported more analysis than any other ether drift experimenters, mentioning the unexplained period 2 pi effect as well as the variation in the phase shift with the period pi effect. Overall, their conclusion was that Michelson and Morley had detected something, but in the end, their reasoning was essentially based on the same argument about the detectable limits of the Michelson-Morley detectable limits as Michelson and Morley used. Yeah, so based on like the 30 kilometers a second for their amount. In the most recent analysis from Correa and others in 2020, who concluded that no ether wind was detected, they spend some time considering the individual curves. They commit the same threefold averaging error that Michelson and Morley did. They distinguish between the curves for which the raw data showing a rise and fall temporal pattern, although they propose no reason for doing so. As figure 1 and figure 2 above have shown, there are rather little evident homogeneity within the rising and falling subsets that would suggest a rationale for combining them. Yeah. A sense of an analytical thinking can be gotten from the quote here. Excuse me. Any measurement falling within 2 standard deviations of the mean would likely fall within the random distribution. The similar shape of all 3 curves suggests a possible common pattern involving at least one harmonic and one subharmonic oscillation. However, all points fall within 2 standard deviations of the mean of each curve type. This is followed by an irrelevant t-test for the mean, although the language in the graphic suggests that the statistical analysis has been done. In fact, there is little more than an elaboration in the impressionistic analysis done by the experimenters 133 years later. Correa and others' analysis portrays the important misconception, which was perhaps more popular in the Michelson and Morley's day than it is currently. When the lower detection limit is established for the measurement process, and then the average effect falls below it, the result is claimed to be due to random error. This ignores the fact that the detection limit for the average of uncorrelated measurements is generally lower and quite often a bit lower than the detection limit for a single observation. It is not uncommon to read proponents of a null interpretation of the Michelson-Morley experiment falling into this quote-unquote detection limit trap. And that's exactly what what was his name? Thomas Roberts did for their analysis. Anyway, in addition, as the quote above shows from Correa and others, the effect used for the temporal variation in the data, which was the point of the experiment, as an argument for random interpretation, they had they used the pattern that was to be detected as an argument for saying that nothing was detected, conveniently ignoring whether there was a pattern at all. Pretty much what Roberts did. He was like, oh, this pattern? This is what it would really look like if there was no pattern and this was just all errors. It would be identical. Just ignoring the fact that there was a pattern.
So the whole thing was just a bunch of defective measurements.
That kept repeating and persisting for 30 years across 3 apparatuses and locations and latitudes. Yeah. All right. The distinction between the importance of the question that Michelson and Morley were asking and the quality of the subsequent analysis is difficult to explain. Conventional methods of statistical interference have been ignored, and a tendency to repeat the over-averaging performed by the original authors, despite the existence of better approaches. For perhaps the first half of the 20th century, one might forgive the analysis that falls below the standards of the 21st century, but nearer the analysis comes to present day, the more argument for forgiveness diminishes. All right, Stone, you want to finish this out?
Yeah, sure.
Thank you, sir.
Why reanalyze? The Michelson-Morley experiment left a legacy of results. It is true that it may seem less than relevant today due to further technical issues about whether its underlying theory was correct or not, as well as better experiments that are focused on the same question. But its short-term effects were considerable, and to some extent, we are still affected by them. Despite the modern view that the results were theory-shattering, reaction at the time was both slow and muted. Electromagnetics researchers had spent 2 generations building up a theory that depended fundamentally on the concept of the ether. Michael Faraday used the concept constantly in his descriptions of electrical and magnetic phenomena, and James Clerk Maxwell felt obliged to supply a mechanistic theory for his equations that absolutely required an ether. True, the longer the ether theory developed without any experiments on its properties apart from its definitional characteristics with respect to light, the more tenuous and ambiguous the whole concept became. Before Michelson and Morley, the belief was that eventually a sufficiently precise apparatus would be developed to detect and study the ether. The Michelson interferometer was that device. Together with the null interpretation, however, the very accuracy of the interferometer had a deleterious effect. If the best device for detecting the ether had failed, then what was the point of repeating the experiment? Evidently, The answer at the time was that there was no point. Michelson drifted off into using his apparatus for establishing a light-based definition of the meter, for which he received a 1907 Nobel Prize, abandoning Morley in the process. Although various electromagnetics luminaries urged further experimentation, only Morley and Miller made any further attempts. And when Miller devoted the rest of his career to ether detection, he met hostile denunciation from the physics community. Perhaps the lesson is that false positive results tend to promote the further repetitions that ultimately show them to be false, while false negative results discourage repetitive work, thus solidifying their apparent veracity. Just after 1887, the quickest to mount a response against the null result were two researchers who profoundly believed in the ether, Hendrik Lorentz and George Francis Fitzgerald. Both clearly understood the mathematics behind the measurements. And so around 1890, they were independently able to propose an alternative explanation. In terms of the description above, they claimed that the two arms of the interferometer, lengths D1 and D2 in my notation, should be multiplied by the sine squared theta of VC, the cosine squared and the sine squared of each theta rooted, respectively, thereby canceling out any difference between round-trip times, irrespective of the value of V. Since this amounted to saying that lengths contract in the direction of motion by a multiplier root of 1 over minus V squared, it has been called the Fitzgerald-Lorentz contraction factor. As he proposed the contraction explanation, yeah?
You see that velocity over there?
Mm-hmm.
You just fudge it.
Oh, you have to fudge it. You have to fudge it hard in there, and then maybe even average it when you're fudging it.
Yeah. As he proposed the contraction explanation, Lorentz was attempting to develop a method of applying Maxwell's equations, which he supposed to be valid in the stationary ether, to an electron moving through the ether. He employed several slightly different space-time transformations for the purpose, the details of which are not important here. These transformations were in effect conversions between the coordinate system of the stationary ether and a coordinate system in which the moving electron was at rest. Oh, give me a break. The moving electron is at rest. Okay, the dilemma faced by Lorentz was that while his discounting of the Michelson-Morley result depended on material objects contracting in the direction of motion, his transformations appeared to make objects expand in the direction of motion. In his final pre-relativity publication on the topic in 1904, Lorentz rehearsed his arguments for his transformation, which was essentially the modern Lorentz one, and then made the subtle implication that it involved a material contraction. It would not be fair to say that Lorentz misinterpreted the situation, but it would be reasonable to say that he muddied it. Within a year, Einstein published his article introducing special relativity, in which he featured the Lorentz transformation as the correct coordinate conversion for uniformly moving systems. In a very short part of that article, Einstein provided an interpretation of the physical consequences of Lorentz transformations. He gave an example of a sphere, which he claimed squashed into an ellipsoid when it moved. He achieved this by the artifice of arbitrarily fixing time in one of these two systems, or alternatively by redefining the meaning of the spatial coordinates in one system, in either case making the supposed phenomenon irrelevant to the experiment, while at the same time promoting the mistaken concept of length contraction. It seems that some maneuver like this is the only way to make a contraction appear consistent with the Lorentz transformation. To see this, let P sub m denote the component in the direction of motion of a rod at rest in the moving system. P sub s be the same component measured by the stationary observer, who takes time ts to determine the two endpoints. And the transformation is here listed, where its lambda is 1 over the root of, you guessed it, 1 minus v squared over c squared. And so ps equals p sub m over lambda plus v ts. In the setting, PM is the component of the length of an interferometry arm in the direction of the Earth's motion through the ether. P sub S is the same component as measured in the coordinate system of the ether. It is inherent in Lorentz transformations that the numerical value of any length depends in part on how long the measurement takes, which in this case is TS in the ether coordinates. Consequently, in order for Lorentz to have the ether length of the arm shorter than the interferometry length by the Fitzgerald-Lorentz contraction factor, the ether measurement would have to be instantaneous. To justify the Lorentz contraction on the basis of the Lorentz transformation, it seems necessary to say that the isotropy of light in the ether requires that the relevant lengths be measured in the ether's coordinate system, and that they be measured instantaneously. If this is what Lorentz meant, then he was not only retraining the ether as the medium in which the light speed is isotropic, but he was promoting the ether coordinates for space and time to be the relevant ones for physical measurements in electrodynamics, and in addition requiring that ether lengths be determined instantaneously. While this is the only explanation I can see for Lorentz's argument, I admit that it is less than obvious in his writings. It would have been simpler to apply the Lorentz transformation directly to the initial Galilean equation and show that it made the round trip times equal. But Lorentz did not take that path. After 1900, there were several unsuccessful experimental attempts to verify the length contraction hypothesis. Their collective failure left physicists perplexed at the result. As we've seen, it is the positive result of that experiment that furnishes a denial of length contraction. Recall that Lorentz was making his argument to claim that the experiment could not detect movement through the ether as a consequence of its design. When Einstein indirectly repeated Lorentz's argument, he was in effect agreeing that M result provided no support for special relativity. It is conceivable that he saw this, which would account for why he failed to mention the experiment in his 1905 article, when he must have known about it from Lorentz's 1895 book.
And that's a good hunch. He did absolutely know about it. We went over the evidence
Probably,
of it.
hey, probably.
He wrote letters to his wife about it.
Quote, wife.
Yeah.
Generations of relativists have repeated the length contraction story as a fundamental aspect of special relativity. In fact, when two uniformly moving observers measures a rod, the one who determines the positions of the two ends more quickly will find the shortest length. This is a consequence of the fundamental invariant of the Lorentz transformations and has nothing to do with movement or stationarity of the rod. Stationarity.
Stationarity. That's one of my new favorite words.
The length contraction meme is one reason for continuing to debate in the current area.
Called it a meme, dude. That's fantastic.
Mistakes made in an otherwise superb experiment caused the leading electromagnetics researcher of the age to create a subtle and probably incorrect explanatory theory, which was picked up by the creator of special relativity and passed along to generations of physicists. If the observed results of the experiment are taken to have been positive, as argued in the analysis here, then there could be several results. First, the null result is supposed to have disproved the existence of the ether, paving the way for the Einsteinian relativity. Whether or not this is historically accurate, it would be physically inaccurate. The constant speed of light required by Einstein occurs in a vacuum, but the Michelson-Morley experiment was conducted in air. If the experiment were null, it would imply that light speed is constant and isotropic in air. But a physically consistent set of Lorentz transformations can preserve only one speed. And if it were the air speed of light, then it could not be the vacuum speed of light. In this sense, a null experiment would disprove Einsteinian relativity, although it would have nothing to say on the obvious question about what would be so special about air. Secondly, A positive MMX experiment would invalidate the counter effect of the FG Lorentz contraction in air. This would not necessarily invalidate it in a vacuum where Einsteinian relativity claimed it to exist. Thirdly, one can only speculate whether a proper analysis of the MM experiment at the time might have inspired broader and faster development of subsequent interferometer experiments, especially ones that could have been oriented to a fuller understanding of what exactly was being detected. Conclusions, plural. There do not seem to have been any proper analyses of the data produced by the MMM. This is partly due to the fact that they gave only average summaries of unpublished individual runs, and partly a failure to take a detailed look at the data they did publish. The analysis here shows unquestionable evidence of the period pi effect they were seeking. It also shows unquestionable linear and period 2 pi effects that Michelson and Morley ignored. Since there are apparent anomalies in the data, it is unfortunate that the experimenters did not follow up their 4 days of data collection with further runs made under different controlled conditions or in other locations and at various altitudes. Michelson and Morley's declaration of a null result was premature and led to the proposal of a problematic length contraction hypothesis that has survived to become part of special relativity. Here endeth the lesson.
Ooh, that was a good read. It turned out to be quite a good read. And I made some preliminary assumptions and conclusions that were not fully substantiated towards the end there. He did reference the boys and all that. So yeah, that was,
it was wild and woolly.
Yeah, it had its ups and downs. It was better than I expected. It was awesome. All right. I think Piezo read it earlier. Do you have any thoughts on it, Piezo?
Yeah, what up, dude?
Yeah, man, I think he's right when he says that the effect demonstrates a linear and a periodic effect. Clearly does. It's clearly not random noise or null. So what does that mean? Well, relativity says that it was null, it was zero, and it's zero because there's no ether, but clearly it wasn't zero and it was a real effect. So what's that say about relativity, you know?
Indubitably.
Chuck it in the wheelbarrow.
All right.
Take it out to
was
the
created to explain a zero, and it wasn't a zero. Then where does that leave relativity? In other
Right.
words.
Relatively dog water. That's where it leaves it.
All right, everyone. Lily is going to tell us about this coffee she just tried. Aren't you, Lily?
Well, yeah, the brushtail coffee, the miracles never ever end. Remember I told you my little neighbor and we've been feeding brushtail coffee grinds to the chickens, and then they were laying these eggs made of solid gold. Well, now they've started laying silver eggs instead of gold. So I think these hens are trying to tell us that we need to have silver. Just saying, I don't know. But see, brushtail coffee grinds, they are miraculous. Yep.
You heard it here first, folks. Put your brush tail in your chicken feed and you'll get golden eggs. Yeah, Gally! For those of you who don't know, Gally's been pretending to be sick and then offering to do services, so it seems like he's such a good guy that even though he's like super sick, he's going to help out. But as he's offering assistance, he continuously fakes his cough and really ramps it up. So anyway, go ahead, Gally.
Right now.
Go ahead, do it, Gally.
I was sick. I can't do it.
All right, Gally's not going to do it.
Get that man a wheelchair.
He passed out. All right. If there are no further questions, comments on what we just went over, we will go ahead and wrap up the episode. Shout out
That was
to
good.
Michael Aiken.
Michael
Michael
Eichen.
Aiken.
I like that.
Michael Aiken.
Michael Eichen.
Michael Aiken. Shout out to the homie here. All right. We'll see you guys on Friday for the Twitter community space. And then, like I said, if there's no presentations for Tuesdays, we'll do a reading night. And then if there is a Prezi, we'll do the Prezi on Tuesday, and then we'll do a reading night on the following Thursday, so that we can get one reading night in per week. If anyone has any submissions for reading night, or they would like to come and join and read with us, our Discord is ethercosmology.gg. Just post the paper in the main chat and tag somebody, tag Galatrax, tag Baron Von Galley, and he will put it in the reading pool. All right, we'll see you guys later in the week. Peace.